Hello everyone. Today we will talk about career optimization. So I hope you guys are really interested, and we will talk about some more good stuff today. Today this is the list item that we will cover today. One about the introduction about me. Second one is about what is career optimization. Why we use that. And the next one is purpose of career optimization. What is the need of career optimization? Next one. What query optimizer do when we do optimization, what will happen? It will reduce the line of code, or it will just improve your performance. So it totally depends how you do. Then we will go through a couple of examples which will really helpful for you guys. You will relate how it's happening. uh, Next one, we'll talk about some tips, like how some tricks you can use. Next one, summarize all the things, whatever we will cover. And at the end, we will talk about some question and answer. If you guys have any issue or any challenge to understand something, we will talk about everything in the last session. So, yeah, so uh, as you guys can see my name, so myself, Harish Vaishnav, and I'm working as a senior software engineer. And it's been a wonderful 4.5 year experience in Time Tech so far. And from last past 3 year, I'm working on BI side, business intelligence side, where I'm working on different BI tools like SSRS, SSAS, SSIS. So if I'm talking about business intelligence, so query is one of the main part which is really important. Uh, Reporting side or the cube side, everything totally depend on queries. So if your query is efficient, then definitely everything will be smooth later. So we can start. So today I'm going to use SQL Server, as most companies using SQL Server for most of the database work, and there are a couple of tools available apart from SQL Server also, so we can use it. But I'll prefer this one because I have a lot of experience on that part, and I've used that, so you guys can relate what is happening. Okay, so the first one, what is query optimization? So suppose you are doing some optimization, and how you will measure that your query is optimized, or optimization happen in your queries. Then you need to see there are 4 points there that you can check. These are the checkpoints that your query is optimized or not. Or I would say your query is optimal when your query perform adequately. It's mean that you did some optimization, but your query will not perform in future if data become huge. So that point will not work in that case. So query should work adequately if optimization already happened in your query. So it should be a tick mark. So first checkpoint is tick mark if your query is optimized. Next one, the resources need to further optimize are expensive. It's mean uh, for optimization we need some further resources to optimize our query, and that is really expensive. It's mean your query is optimized. If you need some further resources, it's mean that you need to buy something, and there is no way to do optimization in SQL Server. If I'm talking about SQL Server, so you did 100% whatever possible in SQL Server. It's mean your query is optimized. No need to go any further resources or outside resources. The third one, um, optimization will only bring a small additional gain. It's mean, suppose your query is already optimized, and there are few things that you might see, okay, I can optimize more, but that will not impact more on your query, or just additional gains. It's mean that there are less possibilities of optimize something, but your query is fine. Then it's no need to worry, just keep that query because your query is already optimized. Fourth one, some other solution render your query unnecessary. Sometimes we might do some kind of unnecessary work to optimize something, which will be a kind of a worse thing to do, because what will happen, sometimes we are trying to optimize a query, but it will become a complex to understand. It will, use so many things which is not useful or not readable properly. So in that case, just leave that part. Your query is fine. No need to do some kind of unnecessary work in that. And at the end, I just mentioned one thing: solve the problem. Try not to oversolve it. So that's the purpose. Optimization is very tricky thing that you should prefer. If you don't know, just try to learn first. Then you will understand why and what part. Otherwise, you will just mess up with your query. So now, this is very interesting part. What is the purpose of query? So when we gather the requirement, from client, then we should be mindful about each and every aspect of requirement. Otherwise, we will write something and requirement was something else. So we will go through one by one. How many results do you expect in return? So we should be, aware that what kind of result we want from database. If we are not sure, like we want 1,000 but we are getting millions of rows or lakhs of rows, then definitely your query is not efficient. You should see what is missing in that part so you will understand. So it's totally depend on the understanding part, how you write the query and what is the requirement. Next one, which parameter would be most effective in limiting? So this is another important thing that we can put some parameter to limit the query. That will more useful. Suppose we just want top 10 record, but still we are pulling all the records, like thousands of record from database. It doesn't make any sense because it will create some load for database CPU. It will time consuming and performance also will be reduced. So we should know what parameter we can use to limit in an effective way. And if we need a smallest set of data, then definitely just go ahead and just do it. No need to fetch all the data, then you are doing some kind of a transformation. And also, why to do that? If we can directly fetch the small set of data, then definitely we should do that. No need to pull all the data. Third one, are there part of query that are poorly constructed? So sometime I can share one example here. uh, we mostly write a query like select star from employee, and where the employee city is or the country is India. So now this is something which is a poorly constructed query. I just want to see the name of employee who belongs to India. Now what I'm writing here, select star from employee where country was to India. Now what I mentioned, the requirement is I just want to see the name, right? Still, I'm pulling all the columns like select star. Star is a very bad choice. Whenever we write a query, be mindful. Whatever column you want to see, just mention that column. Sometimes we are also lazy. We want to see all the columns, but yeah, that's where a poor query occurred. Okay, so next one, how often is the query executed? So that's very important point in terms of performance, because if we are frequently running a query and in the database side we have like millions of rows, then we might need to wait. Once one part of query executed, then we will run again. Otherwise, like we are keep running after 1 hour or 2 hours, then there might be the case where other queries already executing. The SQL server will take time to execute your query. So we should be mindful whenever we create a job to execute any query. We should see if there is any conflict while running this query, if other query is running. So we should change the time. That is also matter. Next one, what are your customers' performance expectation? Obviously, this is really important. What customer expecting, and we are just doing something else. This is what happened with everyone, right? We are expecting something, and client is saying something else. So in that case, discussion is the more preferable thing. Just discuss with them, understand what they want, create a POC, fetch the data, kind of a dummy application, share with them so they will understand. Otherwise, we thought, okay, we will share all the data. It will be a kind of worst thing to do because we don't know what is happening behind the scene. So this is all about the query side. So now we will talk about what optimizer do. So basically, there are four part. What is happening in SQL Server side. So we will talk about one by one. First one is parsing. So parsing, we know the term, but in terms of SQL Server, it's just checking the syntax. So whatever query you have written, it will check whether your syntax is correct or not. And then it will parse for binding. In in binding, it will check all the object and just confirm whatever reference you have used, which is perfect. Suppose you are using different database, and it will check whether the database is exist or the table is exist or the column, whatever you're pulling from particular table. It should be correct and it should be exist. It will just check that kind of binding between all the objects. When it looks good, it will just forward this thing to optimization. Yeah, that's the major part. Come optimization. In optimization, what will happen? It will create a optimization plan. It will create kind of a XML file, or there are text file also available, a kind of a graph where it will show what is happening, like how many joins are there, what kind of indexing is happening behind the scene, what kind of scanning is happening, what table is checking the data for other table, foreign key, primary keys, everything. It will check and it will create a plan that how your query will execute. And after that, once the execution plan is ready, then it will go for execution part where it will execute your query as per your plan. So we can move to next one. Now let's talk about some practical thing, where and what we can do. So there are 5 things that we can do. One is about estimated execution plan. uh, which option is there in SQL Server. We just need to enable that. Another one is actual execution plan. The third one is live query statistics. And the last one, client statistics. So we will talk about each of them. This one just a parsing, so we will not more focus on that part. Last 4 is very really important to understand. So we will go through one by one. So I'm just open SQL Server. Um, so if you guys can see, there is an option which is called display estimated execution plan. The another one is include actual execution plan. The next one, include live query statistics. And yeah, include client statistics. So these are the option available, this which we need to enable that. By default, it's not enabled. So suppose let's talk about specific query. I have one query. And this query written on a very famous database, which is AdventureWorks, which is available on Microsoft website. You guys can go and download it. Then I will share all the queries, whatever I will use as examples, so you guys can use it and understand what is happening, what we discuss here. So I'm just execute this one. So it's pulling 266 rows, and if you guys can see, this is the time, execution time, 3 seconds this query took. Now I want to see what is the execution plan of this. When I click on this, it will show me the execution plan. And we will talk about everything what is happening here. So in this plan, it will start from right to left. So this is the last part which will execute, which will select everything. So before that, so if you guys are aware of indexing, right? So indexing is all about the column which is unique, and a kind of a primary key. If we create a table and there is a primary key, by default it will create a cluster index for that. So an indexing is really helpful when we join with other tables. It will scan the data as per the indexing and find out the right value. So basically, this is what happening here. It will just scanning the index, which is obviously a product ID, a primary key of product table. So it is scanning throughout, and if you guys can see, there are some kind of properties available. You guys can see how many rows are there, how many time it will take, estimated row, estimated execution plan, everything is there. So no need to worry that you are not understanding few things. It's okay. It's very visible that it will scan. And another part, like here, if you see, there is a nested loop. We all know what is loop. Loop is a kind of a kind of iterating process. It will keep checking. So join is also something like that. When we join a table, it will keep checking whatever value match with the column, then it will pull the data. And if you guys can see here, so I'm selecting this table and I'm doing inner join here with the different tables, select order detail, and I'm using a condition here, like what column will map with what. So wherever product ID match with product ID of this table, or there's another condition also, wherever row GUI ID and with the detail rows. So both the table have similar kind of column. We just checking wherever they match, it will pull the data. So now there are two conditions. One is this and one is this. So that's where uh, internally the execution plan created in two parts. One is for this one, where it's scanning all the data for both the column, and second one is this one. If you guys can see tables pool here, it's a kind of a temp table which is created, and on that it will scanning the data, this one. So I would say this is happening and this is also happening in separate, and at the end it will just merge here and it will go and it will just show the result. So this is the estimated one. Again, actual plan might be something else, totally depends. The estimated plan is, it just check how many rows are there, what are the columns, what are the columns are applied for indexing or not. So it is just created on behalf of this. So I'm going to PPT again. So these are the option. We will talk about some kind of the terms whatever used in execution plan. So this part we already discussed about parsing. This is we covered that execution plan, which is estimated one on the behalf of checking the query data, number of rows, what are the mapping between tables. So it will show accordingly. Actual execution plan is about that when you run the query, then it will create the actual execution plan where you will see what is happening, what is the structure behind the query execution. Next one is about, which is quite similar to this, but in this, it will show you some kind of a data transferring or a data traveling from one part to another part. So if you notice, there was, in SQL Server, there was some arrows, so it will show you from where to where the arrow is going. So it's a kind of a light, so you will see. And the last one is about include client statistics. This is about, it will show you like how many number of insert statement, happening in your query, or number of delete statement, what are the select statement if your query is used. So in that case, it will show you the numbers and the CPU time, everything, so many things it will show. So we will talk about everything in detail one by one. So I'm not going to slideshow you because I have to go to SQL servers for few things. So this is estimated one that we discussed here. So if you guys can see the arrows, so in the live one, it will show you, kind of a running arrows. Okay, so few terms which is used in estimated execution plan. So we can talk. What is that? Few things are really meaningful and we can understand. Cluster index, obviously, it is used for improving performance or fetching the data fastly, or I would say quickly. In a short time. So cluster index, seek or scan. So it will scan the data. So if you are doing a join, you might use the primary key to check with other column, and in that case it will scan the data, whatever map with that column, or I would say the cluster index, it will just fetch the data. Next one is sort operator. It is quite understandable, sort operator. So here sort operator used from other thing also, like aggregate or merge join or order by. So by default we know this one. Here in execution plan, it can be used for merge join. It can be used for aggregation also. Aggregation is kind of, if you are doing sum or max kind of functions, these all are aggregation function. Spool function. So I mentioned in the query that spool is a kind of a temporary object it will create for table in TempDB, and it will use that temporary object with scanning or mapping with other column or fetching the data. Instead of again hitting the same table, it will create a separate table, kind of a temporary, and it will just check with that. Next one is hash or nested loop. So it's a kind of a looping. If we have join, then it will keep checking for each value with the respective join table, checking and finding the records and just pulling it back. So we mostly see looping happening if we are using so many joins or a subquery. That is really important. If we are using subquery, definitely there will be some joins because it will keep repeating the work for particular value. Okay, so next one is live. So it looks same, but if we go to SQL Server and there is an option, live query statistics. If I click on this, if you guys can, it's enable. I execute this one. If you guys can see the live query executing, and once it's done, so you might not be able to see if your query is really fast here. So no need to worry that you are not able to see what is happening in live query. I mean live estimated plan. So don't worry, it is exactly the same. And I'm just gonna pull the actual one also, because you will not be able to see much difference because actual and the live, they both are same. This is live and this is the actual one. They both are same. And if you guys can notice, it is exactly the same what was showing in estimated one, this one. So yeah, I mean, most of the cases, estimated execution plan is same as actual one. In some cases, it might be different. So totally depend how you're writing your query. All right, so obviously one thing you guys must be noticed that this query is not optimized. Maybe few people might think, okay, this is optimized, what is missing in that? It is taking around 3 seconds. It's just pulling 274 rows. So you might be wondering what is happening. So we will talk about this, how we can optimize this one and what missing thing here. So one thing definitely I would like to highlight here, this one, or part. Or is something, it will always check in the query side. If it is whether it's match or not, it will keep checking. So it will again create a kind of a looping process here, and that's where it's created in that way. Another thing, distinct part. If we are not sure whether we have unique data or not, then we need to check first, then we should use this thing. This thing is a kind of tricky thing. If there is a need, then use, otherwise it will again rescan your whole data and check whatever repeating thing, it will just show the unique record. So there are two things I highlighted here. One is about this one, and second thing is this. So kind statistics is definitely we will talk about this in the SQL Server side. Here I mentioned this thing is a query killer. If you don't need it, definitely don't use it. It will reduce your performance. Next part, or. So when we use or, I think it's better to use a separate table and join with that instead of using or. It will force a table to recheck again for different column. So I would suggest that not use or. So we will talk about some tricks. What is the alternate of or? So I'm going to this, and I have an optimized version of this here. I'm going to show you. So, okay. So I just divided this query into two parts. As I mentioned, we can do a separate join, instead of or. So this is what I did here. This is a separate part. If you guys can notice, I just divided this thing with the whole query. You guys might be wondering here that why I did that. It will be more expensive. You guys can see the result. We are getting the same result in 0 seconds. So don't you think that it's a optimized way? And if you see the plan here, one thing you might be wondering that the plan is look big. So it's okay because we have two set of queries and we are doing union. One thing I would really want to highlight here, union is not costly anywhere. So you can use it wherever required. Don't worry about it. It will take time. No, it will just, merge your data sets. That's it. So here, what is happening? So it will just doing the same thing, like whatever happening earlier. It will scanning the data as on the behalf of cluster index and just pulling back. And here, the join is happening. This is the union part. So this part is the first query set, this one, and this one is this query set. And one thing, I'm not sure whether you notice or not, so I can again highlight this thing. Earlier in the non-optimized query, we had a loop. And as I mentioned, it's very expensive all the time. And that's where, I divided this thing into optimized way. And this is where there is no loop. If you guys can see, there is no loop, and that's why it is executing quickly. So that's one thing. Definitely you guys notice that or we should not use it if there is no need. If there is a need, then we should go with alternate ways like this. I just use another set. So, and distinct also. I didn't use distinct here. But still, it is executing in the same way. So we can relate the importance of statement right here. Like whether distinct is really important to use, then use it. But make sure that it is not taking time for the query. And you can see from the execution plan. Another thing, or obviously I highlighted this thing. So I'm going to PPT again. This thing we discuss here. Next, as we talk about, distinct part, it will take a CPU time and will keep repeating the things and checking again and again. So yeah, this is the better approach. I'm keeping everything in the PPT so that you guys will, refer that PPT. So I'm putting all the contents here. Yeah, and I explained some kind of, a labeling with the execution plan so that you can relate what is happening here, what is happening this part. I already mentioned that, this part is the first data set and this part is second data set. And this is where union happening. And before that, it is just scanning the data and just pulling back. Okay, so one thing definitely we can see, suppose I want to see for this query, there is another option available, which is client statistics. This will be really interesting for you guys to see. It's taking time. Yeah. So in client statistics, you guys will see this is the first trial because I just executed once after enabling this option. So when you execute, it will show you second trial, third trial, and you keep executing. Here, if you see number of insert or delete update statement, it will show you number of select statement. There are two. How there are two? Because one is selecting from different table also. So don't worry that you are not selecting. It is just checking from which table data is coming. So wherever we are pulling data from table, it's a select statement. And number of rows are there, and there are like packets sent from client. So this is also useful when you are comparing two queries. Then you will see the differences. Byte sent from client, byte received from server. So major part is this. Sometime we might have like thousands of rows query, and we don't know what is happening, and we really need to see wherever delete happen or how many delete happening. So in that case, this will really help you guys. Okay, so I'm going to share with another example, which will be really helpful for you guys. And I have a one messy query here. Huh. So if you guys can see, I have used around like 8 to 10 joins here. And obviously, if in your query there are multiple joins, then definitely this query will take time. But totally depends on data, like how much data do you have in your database side. If there's a less data, so I'm just pulling 200, so obviously it will not take time. It is executed right in 0 second and 200 rows. But what if in future we'll have like millions of rows? Then how we will find a place where we can optimize? And one more thing here, I didn't use any or any distinct, so no need to worry. Now another challenging part. Okay, then how we can identify, okay, wherever the actual time taking part. So if I'll see the execution plan here, hold a second, I'm just getting some chat message. So I'm getting some queries, so definitely I'm gonna go through all the queries at the end one by one. Okay, so this is the execution plan of this query, and here I can see a lot of nested loop because I have used so many joins here. Now, if you guys can notice, it is showing the cost also. What is the cost it's taking? This loop taking 0%. So we can see which loop is taking more time. So this one taking 1%, and this is scanning. Okay, so this one, right? This one taking 1% and this one also. So we can see what is the loop and on which table it is applying. So this one is applying on product review, and this one is applying for product model. If you can see the outer reference here, product model. So we got it. Okay, this is the place, product model, right? So what we can do here? Uh, Here we will talk about another approach which is called temp table. You know, temp table is quite lightweight and useful in terms of we really want to store a particular result set in a table, and we want to use that particular result set into another query site. So I'm going to share what uh, what are the tricks for that. So I just divided the query. If you guys can see, I notice here, the product model. So after this one, the cost increase here. So what I did, I just divided this part into a separate part, and after this one, I just used with the result of the above part. If you guys can see here, this part, it's just a similar. Only thing I'm doing here, I'm just storing all the result set into a product, which is a temp table. And we all know this temp table is available on this session only. If I close this one, it will not be available. And obviously, when you use temp table, it will fetch the data faster than the real table because this is available here only and it is really lightweight. So what I did here, I just created a temp table and I stored all the result of, this query and storing into that. Then I'm again selecting the same data, and what I'm doing it, I'm just doing all the similar join with this temp table. And I'm just at the end, I'm deleting. And this is really important thing that we all should do, that once temp table job done, we just need to delete it. Otherwise, when you execute again, it will show the error that table is already exist. Let me execute this one and I'm going to enable this one and I'm execute again. So it will show the execution plan. The most noticeable thing here is the loops. In the earlier query, we had like 1, 2, 3, 4, 5, 6, more than like 7, 8, right? And currently we are just pulling 200 root. That's why it's not taking time. But what if in future we have a lot of data? Then in that case, definitely this will go beyond and it will take time, maybe around 5 to 10 minutes. Here, there is only one loop and we all can see if there are less loop, definitely loop is always time taking. And we have only one loop. And this loop is about, joining with the temp table, what we did here. And you guys can see there are two parts because we did two section here. One is storing data into temp table. Second one is we are joining all the tables with that temp table. So that's where it's showing two. But you notice that in execution plan, there are less loop, right? And that's where we see this is optimized, or I would say optimal query, where we need not to worry because in future, if data will increase, definitely it will not take time to execute. So that's another example. Definitely, you guys must be thinking there's another alternatives available here, which is table variables. So this is what my next example. Sometimes we might confuse either to use a timetable or a table variable. So there are a few things that we can discuss first. So there are a few requirements, right? What is the requirement? Then on the basis of requirement, you can choose whether it should be a timetable or a table variable. First thing, there are a few limitation in table variable, which is like we cannot create indexing with the table variable. So if we need indexing, or by default, definitely for primary key there will be a clustered index. But what about other columns? Sometimes we might need to create indexing for other column. So in that scenario, definitely table variable won't be the right choice. So we will go with temporary table. Next point, table variable cannot involve in transaction logging. So transaction, we all know transaction, which means something, suppose I want to roll back, I want to check whether I want to delete something and I want to roll back, or I want to truncate something, I want to roll back. So in that case, temp table will work, but table variable will not work. But if there is no need of any transaction things or logging or locking, then definitely temp table will be a bad choice, because we can directly go with table variable, we can use it. Uh, Next one is about schema. We can see table schema like a column size and all, right? So in table variable, we cannot modify. I mean the schema part in temp table. So that is something, if we really want to update the schema, then definitely we should be wiseful in terms of choosing this. But if you're sure you will not update the schema, then definitely just go for it. This is really important. Sometimes we might need this. Table variable can be passed as a parameter to function or in store procedure, but in terms of temporary table, we cannot. The reason why we cannot, because temporary table is available for particular session, or I would say the window. When you close this, it will not be available. So obviously you cannot pass it. I have an example here. Let me show you for temp table and so if I execute this one, oh, so I'm going to execute this. Okay, because the same thing happened. I didn't delete the temp table here, and it is causing issue. So I just deleted and I will execute again. Yeah, so around 19,127 rows I'm fetching from the temp table. And I just use the direct temp table here. Like, I didn't create a schema for that. I just use it, whatever data is coming from this. So, and here, the temp table variable here, there are the columns I created and I'm just using. So both they were returning the same rows. Now, uh, there is an option in SQL Server Profiler. So I'm just going to open. Oh, it's already open. My bad. Yeah, so it is already open here. So I'm just going to down. It will show the latest thing below. I'm just going to execute both queries, right? And I will see what is happening here. So this is the temp table. And if you guys can see, CPU usage for temp table is 226. For table variable, it's 250. So there is not much difference. But in terms of read, then you guys see the huge difference between timetable and table variable. They're like 2328 and like 1,33,788. This is also similar. This is little different, but it's fine. And being a developer, reads are really important. How many reads happening? We keep reading multiple time, then definitely it will time take. Uh, what will happen if you execute again? You will see the different number because the session has been stored. So they will be less, but yeah. But the difference you will clearly see about timetable and table variable here. CPU uses and the reads. Remaining things are not that different, but these two part is really important. We should be, thoughtful that why it's taking time. And another thing I really want to highlight here in table variable, joins are always expensive. So if you think that you will create a table variable and you will keep joining with different table, definitely it will take time. And obviously, as I mentioned, there will be no indexing, and that will another cause that the query will take time because you cannot create indexing for table variable. You can create a unique row, unique identity column, but the indexing won't possible. Same like in template table, definitely we can create that part. And joins are really healthy with temp table. It will act similar as a normal table, but in terms of this, it's not. So now, as a conclusion, I would say if you have less data, then definitely I would suggest go for table variable. But if we have used data and there is a need of like joining multiple tables, or there might be the case where you need to create indexing, then in that case just go with template table. That will be helpful. So this is all about table variable and template table. I hope you guys got something. So at the end, I'm just going to share the tips, like tips for optimization here. Productive index. So it's really good if we have indexing in tables. So it will help us to scanning the data and fetching data fastly. Optimal table joining order. Obviously, it's matter. Uh, if you are joining, like big table first and small table later, then definitely it will take time. So just see which joining part is taking time, so that part you can join first. Then which table have a lot of data and it might take time, just join at the end. So it's a kind of order which matter when you write a query. Next thing, avoid nested loop. Obviously we discuss about it. Whatever nested loop is there, just try to break it. See what you can do. You can do union, you can use temp table variable, whatever. Just see what you can do. Or base condition is always costly. Obviously, it's costly because it's checking 2 times the same process, and it's not a good choice. Next one is yeah, as per the requirement, choose temp or table variable. So yeah, uh, it's really matter. Depends on requirement. And the last one is hint for SQL Server optimization. So currently, we don't have any that query which shows some hints, but when you see the execution plan, sometime the plan will show you some hint. Okay, you can create indexing, or you can I mean the particular column also it will mention, okay, for that column you can create indexing part. So that's somewhere you can see what is the place and what is missing in the query. So that is also helpful. When you go through the execution plan, you will get it. So these are the links that I referred, and you guys will see there are a couple of examples there. So today we discussed about the introduction, what is query optimization, the purpose of query optimization, and we gone through a couple of examples and some tips also. So now so it's time for some question answers. So definitely anyone has any question, then please share. You guys can unmute and share. You can ask. I'm just getting some chat. I'm just stopped sharing. I'm going through all the okay. So one question I got from Manmohan Batana. It looked like optimized and non-optimized version returning different row count. So is distinct not working? Then here the optimized query is doing the same. So uh, I didn't notice that part, but yeah, if it was the case, then definitely I would say you can remove. I'll share this query, and I'll share the query, and you guys can see what is happening. This thing I just used to highlight what is causing the issue, and why it will take time because it will keep scanning after fetching all the result. And another thing is that or part, which I already mentioned. So in the first query, there were two parts. One was about distinct and second was about or. So there are two parts, which is taking time, and we need to find alternate ways. And another thing I got from soon, I believe, Unis also select the distinct value result set. Yeah. So it's a good thing which highlighted person that we did a union after breaking the query. So union is also doing a distinct, and that's where we use as an optimized way with union. We replace the distinct part and also replace the or part, and we created two data set with union. So that's where exactly a distinct happens. I didn't get any other query here.
Actually, Harish, here, if union is doing distinct, with the first query to second, then
Yeah,
it should return the same result. So what I see is like union is not doing distinct, or like the first query is not like something is going
maybe
wrong there
I
because
can, yeah, I can share the screen. Maybe we can just work on this part.
yes.
So this is the distinct part, and how many rows we are getting here. There might be some 266, and how many we are getting here.
I think here we have added select top 200. That is why it is.
No, no, this one,
Okay,
this is
okay,
the
okay,
query.
okay.
Yeah, this is the same, by the way.
Okay.
We are getting the same row,
Okay.
266, and well, anyways, I will share all the queries set and the PPT, as well as I'll share the links also, whatever I refer. So you guys can refer that part. Thank you so much for attending this session, and I hope you guys got something out of this session, and we will keep talking. We will share this PPT on YouTube, and I mean the video recording, so you guys can post your queries and all. I would say thank you so much, guys. Have a wonderful day. Bye.